Hi everyone, my name is Shao-Chieh, and today I'm going to present our project, the Autonomous Vehicle Speed Detection Library. I'm the leader of this project, and I am in charge of developing the speed detection library. Christopher, that will present later, is in charge of the data generation, while Meenakshi is in charge of paper writing, who will also present later. Since the rise of Tesla, lots of car manufacturers, like Honda and Toyota, now is trying to transfer their car into autonomous driving car. Lots of setup like the speedometers are being transferred from hardware-based into software-based because it will be more flexible and easier to integrate with the autonomous driving system. Nowadays, there exists different software-based speed detection solutions to replace traditional hardware-based speedometers like the high-cost LiDAR developed by Waymo from Google. Each LiDAR could cost more than $1,000. Our solution will be focusing on using the dashboard camera, which is already in the car, and combine it with AI, machine learning, and image processing technique to detect the speed of the car. Because any dashboard camera that could output the video will work, our solution will be cheaper than the high-cost LiDAR. Our main deliverable will be provide a speed detection library that could accept video input and then output the speed of each frame in real time. Here is an example of our project result. So now I'm going to briefly talk about our software and repository architecture. For our library, we use the module from OpenCV, Matplotlib, NumPy, and Keras. OpenCV and NumPy will be used for image processing to reduce the noises and to reduce the latency for later training. And then we will use the Keras model to train the neural network and then use the trained model to detect the speed of the car. As for our repository architecture, it will be parallel workflow with feature branching model. My job is to develop the main speed detection library, while Christopher is in charge of generating training and testing data. Later, he will push the data into the main branch of our repository as a new feature. As for Meenakshi, her job is to write a research paper about our finding, so her workflow will be parallel with Christopher's and mine. Now my teammates Christopher and Meenakshi are going to share about their work in this team.
Hello, my name is Christopher Crocker and this is my midterm design overview. So I will be discussing my role in the project, my current progress, what I've done in the last 7 weeks, and my likelihood of finishing by week 13. So my role in the project, I am writing scripts that will generate training data for the AI using the Carla Autonomous Driving Simulator. I will then use those scripts to generate 12 roughly 10-minute long videos that we're going to use to train the AI with. And then finally I will be writing the data generation section of the paper to explain how and why I did what I did. My current progress. I have made 2 modules for my section. I've made the simulation/recording script and the video maker script. The simulation/recording script runs Carla and connects to the Carla server, which also runs on my computer, and it allows me to control the car and record video. My second module takes the raw data recorded by the sim and creates a video and a .text file which contains the y values for the neural network to train on, which the y values are the speed of the car in kilometers per hour at any given frame. I've also created one of those videos so far. What I've done so far, I have created the recording script which allows me to drive the car, control the weather, record high-resolution video in as raw bytes, and change the map. What this script cannot do is control the traffic flow, which I have another script for that I did not write. That came with the download on the simulator. I cannot create my own maps, and the script does not output the actual .mp4 video because I had a lot of issues with the CPU usage and how that affected the frame rate of the simulator. So my solution to that problem was to write another script which takes the raw data and compiles it into a .mp4, as well as creating the .text file. I believe that my likelihood of finishing by week 13 is very high because, aside from one small issue where I had problems with the image quality on the video when recording at a lower resolution. But so I've since fixed that problem, and so aside from that one issue, I've stayed on track very well. So I believe that I will be able to finish no problem.
Hello, my name is Meenakshi Pavitran, and this is my Senior Design Midterm Presentation Overview. In this presentation, I will be talking about my role in this project, my current progress, what I have done so far in the past 7 weeks, and finally, I will talk about my likelihood to finish my task by week 13. Starting off with my role in the project, I am responsible for writing and publishing a research paper on our model. Therefore, I am dealing heavily with the documentation side of things. I will be explaining our solution in a research paper. At the moment, I have chosen Archive to publish our paper on, and right now the paper has a clear outline with sections and subsections. The introduction paragraph is also completed. Now, when it comes to what I have done so far in the past 7 weeks, I have found a potential archive where we can potentially publish our paper, and that is ARXIV. I've read scientific papers about neural networks that were published on Archive and also on other publications, and I have made notes on it. I've also noted how the introduction, the solution, and the conclusions were all written in these papers that I've read. I've studied our ANN model and solution and wrote paragraphs about it as well. I've created an outline for the paper and wrote the first section, that is, the introduction section. The likelihood of finishing by week 13 is pretty high, because the current plan is to finish the related work section and the proposed methodology section by the end of this week. That would form the bulk of the paper. Basically, from here on out, my work would be using the notes I have taken in the past 7 weeks to write our paper. The following weeks after this week, I will be dealing with writing the results and the conclusion. After that, I would be revising the paper, and thus, I believe the likelihood of finishing my work by week 13 is pretty high.
Thanks for Christopher and Meenakshi for sharing about their work in this project. For code review policy, we are going to base on the SMART criteria to set up the external metric for new features. The feature will be automatically tested with a pre-written test script and then analyzed with flag 8. Only the code that passed step 1 and step 2 will then be peer reviewed by each of us to ensure the code meets the external metrics for the new features. The last step will be given feedback, approve or reject the feature branch. For CI and CD, we are going to use the workflows provided by GitHub Action to test the new commits. You could isolate in the environment and run the testing script on different OS and Python version. For example, in the right picture, it is a YAML script that we use to integrate our code. It is run on Ubuntu latest OS with 2 different Python versions, 3.1 and 3.2. It will be tested with the car speed detection test.py using PyTest to check if the new commits meet our requirement. For quality assessment, we use static analysis tool flag8 to analyze our coding style, comments density, and reduce the redundancy to make our code clear. For example, in the right graph, one of the building results, you can see that some included libraries are not used, which creates redundancy. For our security design, we plot the data flow diagram first to figure out the loophole that the hacker may use to sabotage our library. As can be seen from the data flow diagram, most of our functions need to get the data from database in order to read, train, or detect the speed of the car. If the hackers manage to hack into the database or intercept the data transmission between the cloud and the car, like the attack tree shows, it is easy for hackers to feed in tampered data to make our library behave unpredictably. Our countermeasure is to provide the attack tree in a documentation so the user could be aware of the potential threat that might occur if their database and transmission channel is not well protected. In our project, there are 5 smart requirements that we set up in the final proposal. The first 2 are to develop a good preprocessing pipeline and a good ANN module that to detect the car speed from dashboard camera. They have been tested successfully by our testing script with results of MSE less than 10. Some of our criteria are still in progress, including packaging and publishing the model on official Python packaging index. Provide well-documented API including Q&A and record of our development process for future developers. We have finished the preprocessing feature, training feature, speed detection features. The CE module trained with our library has mean square error less than 10. Our library has passed all unit testing and end-to-end testing and are ready for a beta release. Before the beta release, we still need to package our library and document our API for the speed detection library, which should take less than 5 weeks. Now I'm going to demo our project. Because it would take some time to read and also process the training data to extract the feature, I'm going to mainly demo how the neural network reads in the feature data, train the model, and how we visualize the result. You can see in the feature.txt, there are totally 48 features in each row with its corresponding speed. We will then use this feature.txt to train our model. First, we run our library, and then the training function. Because our library could check the speed of the car in real time, for 1 minute testing video in this case, it will take around 1 minute to detect and output the speed of each frame. Now we run the combine video and speed function to combine the video and the speed text together, so we could visualize the speed of the car in a video. Now let's hit the refresh button and download the output video. From the video, you could see the speed of the car was attached on the video, and you could see how the car speeds up and also slow down to wait for the traffic. This is the end of our project demo. If you want to play with our library, feel free to click the link and use the training data and testing data to try out our library. If you want to contribute to our project, feel free to click the link to our GitHub repository and add in new features that you think will be helpful for our project. If you have any questions, feel free to contact me at lians@purdue.edu. Thank you.